Again, lecture number 2, on the third part of this lecture. We have to finish this example first. For example, this chart flow from station M2. Catchment area of this station is 4,800 square kilometer. So it's like we have this catchment area. Okay, this is area A, and this received the annual rainfall is P. Okay, so we can write the given data. This means area A is just to bring out the symbol and the number from the problems for 4,800 square kilometer. Q is about 535.10 power 6 per year, and P is 1,000 millimeter per year. So we want to find how many percentage of rainfall convert to runoff. Okay, how many ratio of the QOP in percent. The solution we have to find the first to find the discharge Q in terms of the millimeter, so we can divide the volume divided by area. Convert 4,800 to square meter. Okay, and we have to multiply by to convert from meter to, so this one is cancelled. So we got meter, and we convert to millimeter by multiply time by 1,000. We got about 111.5 millimeter. So we can compare to the P with the same unit. Okay, so it means only 11% of the rainfall convert to runoff. The next topic is about the catchment boundary and the area of the target area. Okay, so this figure shows what is the catchment area. So we can define what is the watershed divided. Watershed or the catchment is the same meaning. Okay, so if we can divide it, it means the precipitation come to this area and flow out. Okay, flow in and flow out on this area. So it means the water from precipitation is come together to one outlet. Okay. So how to define the watershed divided and how to define the boundary of the catchment, we can have to use the topographic maps, okay, to identify the catchment boundary and area. And the next slide will show you how to find. So this is topographic map, but it's poor quality. You can see that the scale is 1,000, 50,000. Okay, the scale of this map. And the question is, we want to find catchment boundary and area of the one small subcatchment ห้วยซับผักหนอก Okay, if you look at this map, this area is difficult to see. This is ห้วยซับผักหนอก The first thing we have to identify the stream line, the stream. So we can, if it's not clear, you can look at that. Is the ห้วยผักหนอก is start from here. Okay, this is the ห้วยผักหนอก flow is flow to the, this is mainstream. Okay, in the topographic map, you can see in is a small blue line in the map. Okay, the next we have to draw the watershed divider. This is outlet of the ห้วยผัก this is outlet. Okay, so we start to draw the watershed divided from this. Okay, so it means, what is meaning of this? It means if the rainfall flow on the left hand side, it will go to the ห้วยผักหนอก, but go to the right hand side, it go to another subcatchment. Okay, that is the meaning of this. We can draw the watershed divided. This is like the top of the hill. It's similar to this one. So if the flow on the top is going another subcatchment. Okay. It's easy to draw on the left to the right. Okay. You can, at the top of the hill is like the shape is like a circle. Okay, another part. Okay, so that is the left right is the catchment boundary of the ห้วยซับผักหนอก If you count the grid areas, we can estimate that the area is about 6 square kilometer. Okay, that's how to define the catchment area. Okay. This show more clearly about the topographic maps in the same scale. Okay. In this the black line is a stream line, or the water. This is a stream line. is the lowest part of this area. Okay. Okay, if we want to know what is the catchment area of this point A1, okay, so we can draw the watershed divider start from this point. That is the catchment boundary for the. It means the water, the rainfall will fall on this area and flow out at this A1. So the catchment area is about 34 square kilometer for the catchment A1. Okay, you can practice to draw what is the catchment boundary for the A2. Okay, let's start. Give you some idea. You can start from here. You can draw to the top of the hill. On this way. Okay, let's give you can complete by yourselves for the boundary of the A2. And from the whole country, we divide the Thailand into 25 catchment. That will show you the location of the 25 sub-catchment. We stay our university is located in the Moon River basin on this area. This is the Kolasima province. And we enlarge the Moon River. You can look at the next figure for the Moon River. This one for the Moon River. And we can look at this. This is Lampakong River where we are. Is located on the upstream of the Moon River. Okay, if we expand this, expand the Lampakong River, is look like this. Is Lampakong River. And this is the Lampakong Dam. The Kong Dam and reservoir, and this is where we are. Is at Hue Ban Yang reservoir. If we expand the catchment area of the Hue Ban Yang, we can look like this. But the Hue Ban Yang is in this. The boundary of the Hue Ban Yang, the area is about 36 square kilometer. This is the boundary of the SUT. There is about 10 square kilometer. So our university is located in the Hue Ban Yang catchment area. This is the catchment is a Hue Ban Yang reservoir on this location on the top, on the north of this area. And from the contour topographic map, we can use the function in the GIS software to draw the picture in terms of the color. You can expect that the red color is a high area and the green is a lower area. So you can see that in the case number 2 is the highest elevation on this area. Case number 2, okay, is the highest area compared to the other part of the SUT. The final part, I mean to introduce how to get the topographic maps. Okay, if we do surveying from the area and we draw the grid line on area and use the leveling to measure the elevation of the surface on this grid line, we can got information like this. Too thick. Okay, this is a spot elevation. At each grid line we measure the elevation 16-15 meter. Okay, from this spot elevation we can do some interpolation if we want to draw the contour line. Okay, if you want to draw a contour interval about 2 meters, so we can do interpolation from this spot elevation. The first, for example, from this point 15 to 18, so we can divide into 3. This one 16 and 17 or something, and from 12 to 15, so we can divide into 3. Something like this. And from 14 to 18, so we have divided into 4 parts. We can divide into 13 to 15. This means 14 somewhere here. 13 to 16 divided by 3. 12 to 15 divided by 3. 13 to 16 divided by 3. Okay, so now you can see the first lines of just look at the on this one from 13 to 15. Okay, you can look at the first lines adjustment 14. Okay, we can connect the line between 14 to interpolate point. Okay, for example, okay, so you can connect the 14 to 14 to 14 to 14. Okay, that is a contour line for the 14. Okay, the next, we can draw like the 16 because every 2 meter. That is lines for the 16. And how about for 12? You can from 9 to 13. This one is 10. 12 here. 10 to 13. So the next we can draw the 12 contour line. Okay, the 12. And the next is for the 10. Is it 16 another line somewhere here? Okay, that is how to draw the contour line based on the contour interval 2 meter. Okay, give you some idea how to draw from the interpolation from the spot elevation.